Hi friends, welcome to our YouTube channel Naraj Academy. The main aim of this lecture is to discuss about the ESE General Studies solutions of the 2021 in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever you upload a new video, the direct notification comes to mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why do waste more time? So let's get started. So now we are going to solve the first question. See the question here. If u is equal to x cube plus y cube, where x is equal to a cos t and y is equal to b sin t, then du by dt we have to figure out. So what are the four options? Option A is the correct solution of this question. So let's solve this numerical. So in the question they are given u is equal to x cube plus y cube. So a is a function of x and y, where x is equal to a cos t. So it is a function of t variable, and y is equal to b sin t. Y is a function of t variable. So in the question they are asking what is the value of the du by dt. So here in place of x and in place of y I am going to substitute what is the value of x and the value of y. So therefore u is equal to a cos t whole cube plus b sin t whole cube, and if you expand this one we are going to get a cube cos cube t plus b cube sin cube t. So now I am going to apply the derivative on this one, du by dt. So a cube is a constant, it is outside. Cos cube theta differentiation is 3 into cos square theta, and cos theta cos t differentiation is minus sin t, and similarly b cube is a constant which is outside. Sin cube t, the differentiation is 3 sin square theta, and differentiation of sin t is cos t. So after rearranging this one we are going to get finally minus 3a cube cos square t sin t plus 3b cube sin square t cos t is the correct solution of this question. This is the derivative of the du by dt. This is the correct solution of this question. So now we are going to solve the second question. See the question here. The highest eigenvalue of the 2 by 2 matrix is. So the matrix is 1, 2, 4, 3. For this matrix we need to find what is the highest eigenvalue. So what are the four options? Option C, 5 is the correct solution of this question. So let's solve this numerical. So this is the matrix A is equal to 1, 2, 4, 3. For this matrix we need to find what is the highest eigenvalue. So to figure out that one, first we need to find what is the matrix A minus lambda I. So A minus lambda I. So after solving this one we are going to get 1 minus lambda, 2, 4, 3 minus lambda. So for this one, in order to find the characteristic roots, we need to equate this determinant to 0. So therefore determinant of a minus lambda is equal to 0. So therefore here 1 minus lambda, 2, 4, 3 minus lambda, determinant is equal to 0. So therefore this is 1 minus lambda into 3 minus lambda minus 4 into 2, 8 is equal to 0. So therefore after solving this equation we are going to get lambda square minus 4 lambda minus 5 is equal to 0. So same thing I have written here. So minus 5 we can write it as minus 5 into 1. So therefore here minus 5 into minus 1 is minus 5, and minus 5 plus 1 is minus 4. So by that, so lambda square minus 5 lambda plus lambda minus 5 is equal to 0. So take the lambda in these two terms. So lambda minus 5, take the 1 is common in these two terms. So 1 into lambda minus 5. And in these two terms lambda 5 is common. So therefore lambda minus 5 into lambda plus 1. So lambda is equal to minus 1 and 5. So these are two are the eigenvalues. So out of this the maximum eigenvalue is 5 and the minimum eigenvalue is minus 1. In the question they have asked only what is the maximum eigenvalue. So therefore 5 is the maximum eigenvalue of this matrix. So now we are going to solve the third question. See the question here. If A is equal to minus 1, so this is the matrix here. For this matrix, then the rank of the matrix A is. So for this matrix A, we need to find what is the rank of the matrix. So what are the four options? Option here 2. 2 is the rank of this matrix. So let's solve this numerical. For this is the matrix. For this matrix, we need to find what is the rank of this matrix. Generally, there are two types of transformations we are going to do for any matrix. This is the first transformation, means we are going to interchange the rows, and the second transformation we are going to add the rows. So therefore the first transformation is going to change the determinant of the matrix, but the second transformation is not going to change the determinant of the matrix. But by using these two transformations, we cannot change the rank of the matrix. So here listen carefully. Determinant is going to change only for the first transformation but not for the second transformation, but the rank is independent of these two transformations. Means no matter whatever the transformations you do, still the rank is not going to change by these transformations, but determinant is going to change by the first transformation but not by the second transformation, and the rank is not going to change no matter whatever the transformations you do. So now we are going to do transformations basically of this and this one. So therefore the rank is not going to change, means we are going to simplifying the matrix. So basically what I am going to do is, now I am going to make all this as zeros. By using the transformations I want to make all this as zeros. So basically R2 plus 2R1, then I am going to get this term as 0, and similarly R3 plus 3R1, then I am going to get this as 0, and similarly R4. So first row, second row, third row, fourth row. So fourth row R4 is equal to R4 plus 5R1. Then I am going to get this term as 0. So see carefully, same thing, the first row I have written same thing, minus 1, 2, 3, minus 2. Now here, the second row is R2 plus 2R1. So 2 plus 2 into minus 1, which is 0. And now here, minus 5 plus 2 into 2, which is minus 1. And similarly here, 1 plus 2 into 3, which is 7. And here, 2 plus 2 into minus 2, which is 2 minus 4, which is minus 2. So minus 2. Same thing for each and everything, you have to do that thing here. Whatever I did for the row 2, same thing you have to do for the row 3 and also for the row 4 in the same manner. Then we are going to get like this. So minus 1, the remaining all the elements below this minus 1 are 0. So if you see carefully, again what I am going to do is, this R3 and R4 are same, which is 0, minus 2, 14, minus 4, 0, minus 2, 14, minus 4. So now what I am going to do is R4, I am going to replace R4 with R4 minus R3. And similarly R3, what I am going to do is R3 minus 2R1. Then after doing a simplification, finally we are going to get, this is the way. So if you see carefully, there are only two non-zero rows. Only two non-zero rows, and these are zeros. These are purely zeros, but these are non-zeros. Means at least one of the element in that row is non-zero. See, at least one of the element in this row is non-zero. At least one of the element in this row is non-zero. That is said to be a non-zero rows. So there are two non-zero rows which are present in this matrix. So therefore we can say the rank is equal to, basically rank is going to tell you about the number of independent rows or number of independent columns. Both are same. So here there are only two rows which are independent, and remaining two rows are dependent upon these two rows by any linear combination. So therefore we can conclude that there are only two rows which are really independent, and remaining two rows are dependent upon these two rows by some other linear fashion. So we can conclude finally the rank of this matrix is 2, means only two linearly independent rows or columns are going to present. That is the solution of this question. Only two non-zero rows. So therefore rank is equal to 2. By using this transformation, the rank of the matrix is not going to change. So by using the transformation, we are not going to change the rank of the matrix. Always the procedure is always for the first remaining all things you have to make 0. That is the first procedure. And similarly the next thing is you have to go in this fashion in order to get the identity matrix. Like that you have to do. But in the first case itself we have made like this. So now we are going to solve the fourth question. See the question here. If A is equal to that matrix, then which one of the following is the correct? So basically this matrix is given. We are going to find out of these four things which statement is correct. So out of the four options, option B is the correct solution of this question. So let's solve this numerical. So this is a matrix A. So I want to know what is the characteristic equation of this matrix. So therefore determinant of A minus lambda is equal to 0. So this will become, these coefficients will become 1 minus lambda, 0 minus lambda, 3 minus lambda. Remaining everything is same. So 1 minus lambda, 3 minus lambda, remaining terms are same. Now I need to equate it to 0. So determinant of this one. So determinant of A, B, C, D, E, F, G, H, I. Determinant is equal to A into this EI minus FH. Then minus B into DI minus FG. And similarly now plus C into DH minus EG. So by using this formula, we have made this equation by using that same formula. So A, B, C, D, E, F, G, H, I. So all these terms are we made by using that formula. We have made this equal to 0. By after rearranging, we are going to get lambda cube minus 4 lambda square minus 3 lambda plus 11 is equal to 0. So by Cayley-Hamilton theorem, we know that the matrix is going to satisfy its own characteristic equation. So in place of lambda, we have to substitute that matrix A. Means by Cayley-Hamilton theorem, the characteristic equation is going to satisfy its own matrix. So therefore, in place of lambda, you have to substitute matrix A itself. So therefore, A cube minus 4A square minus 3A. Here 11. 11 means there is a nothing. So we have to keep here identity matrix is equal to 0. So basically this is an equation, but this is a matrix. So therefore this is a null matrix. 0 indicates it is a null matrix. But this is all things are matrix, but this is an equation. So therefore by Cayley-Hamilton theorem, the matrix is going to satisfy its own characteristic equation. So therefore in place of lambda, substitute matrix A, then we are going to get this as an equation. It's the correct solution of this question. So now we are going to solve the fifth question. See the question here. The value of integration 0 to 1, 0 to x square plus y square into dA, where dA indicates the small area in the xy plane. So we have to find what is the integration of this value. We need to basically figure out. So what are the four options? Option B, 1 by 3 square units is the correct solution of this question. So let's solve this numerical. So this is the integration. Integration x is equal to 0 to x is equal to 1. This is the range of x. And the range of y is equal to 0 to y is equal to x. So this is a function x square plus y square into dA, where dA is the area in a xy plane. So in a xy plane, small area. So this is x plane and this is x plane. This is x line and this is a y line. So this is the plane is xy. So if you take any small area, so this is nothing but this length is dx and this length is dy. So therefore the small amount of area is equal to dx into dy. So in place of dA, I am going to make it here dx into dy. So first thing is I am going to do integration with respect to y, and then I am going to do integration with respect to x. So first thing is here I need to keep here dy into dx. So now I am going to do integration with respect to y. So whenever you are going to do integration with respect to y, the remaining variable you must treat as constant. So x is treated as a constant. So x is a constant, so anything in constant is nothing but x square into y plus this is y cube by 3. So now I have to substitute the limits. Y is equal to 0 to y is equal to x, and the remaining thing is dx. So first thing is in place of y is equal to x is x cube, it will become x square into x is x cube, and similarly x cube by 3 minus of, now substitute the limit 0. So anything into 0 is again 0, 0 cube by 0 is again 0 into dx. So if you solve this one, we are going to get x cube plus x cube by 3 is nothing but 4x cube by 3 into dx. So now we have to do integration with respect to x. So therefore 4 by 3 is treated as a constant, so it is a outside the integration. So 4 by 3 integration of x cube is x to the power of 4 by 4. Now we have to substitute the limits x is equal to 0 to x is equal to 1. These are the limits. So therefore 4 by 3 into upper limit 1 by 4 minus lower limit, it is 0. So therefore if you solve this one, we are going to get here 1 by 3. So therefore this is the correct solution of this question. So integration of this total equation is 1 by 3. So now we are going to solve the sixth question. See the question here. 4 men are chosen at random from a group of 3 men and 2 women and 4 children. The chance that exactly 2 of them are children is. So in this question they are given a 3 men, 2 women and 4 children. So out of this we have to make a 4 persons. In these 4 persons exactly 2 children has to be present. So what is the probability of occurrence of this one? So what are the 4 options? Option D 10 by 21 is the correct solution of this question. So let's solve this numerical. So basically there are 3 men, 2 women and 4 children. So out of this total we have to make a team of 4. In this team 4 there has to be 2 children, and the remaining 2 can be either men or women. So they can be anything. So any of them can be either men or women. So now we need to find what is the probability of occurrence of this one. So the number of ways, therefore out of this total people are 3 plus 2, 5, 5 plus 4, 9. So total 9 people are there. Out of this, how many teams we can make of 4 teams? Means how many teams of containing 4 people, which is 9C4. So total 9C4 teams we can produce, which have a team of 4 people. So now here, how many ways we can make a children? So there are only 4 children. So out of this, how many ways we can make it 2 children? So therefore 4C2. This is a 4C2. And similarly, so therefore men and women. So men and women. 3 plus 2 is 5. So we need only 2 people. So therefore number of ways we can make. So out of 5C2. So therefore this is 5C2. So if you make 5C2 and 4C2, then only this event is going to happen. So therefore you have to make a product. Suppose if this event is happened any by one term, then we have to make a sum. But here if these 2 terms are going to present, then only we can make a 4 people. Means we have to make these 2 people select and also these 2 people select from children. Then only this 4 team is going to present. Then only we have to make the product. So 5C2 into 4C2 means the number of ways we can make 2 people from either men and women is 5C2, and the number of ways we can select 2 children from 4 children is 4C2. So by total the number of ways we can select 4 people from all this team is 9C4. So if you do this one, we are going to get 10 by 21. So this is the probability of this making 2 children exactly from 4 people. So now we are going to solve the seventh question. See the question here. The diagonal of a rectangle is root 41 centimeter and its area is 20 square centimeter. So the perimeter of the rectangle is. So basically they are given a diagonal and also its area. So we need to find what is the perimeter of the rectangle. So the 4 options, option B 18 centimeter is the correct solution of this question. So let's solve this numerical. So this is a rectangle. The sides are, opposite sides are length equal, and this is a BB. So the diagonal of this rectangle is under root over A square plus B square by Pythagoras theorem. So the diagonal length they have given, which is under root over 41. So therefore a square plus b square is equal to 41, and the area of this rectangle is 20. This is a into b is equal to 20. So we need to find what is the perimeter of this rectangle. So a plus b plus a plus b is equal to twice of a plus b, means what is the total length of this circumference we need to figure out. So it is 2 of a plus b. So that is the thing we need to figure out. So therefore I want to know, so we know the value of a square plus b square, and we know the value of ab. So I want to know what is the value of a plus b whole square, which is a square plus b square plus 2ab. So a square plus b square is 41, and 2 into ab is equal to 20. If you solve this one, we are going to get 81. So 81 is 9 square. So therefore a plus b is equal to 9. So I want to know what is the perimeter. Perimeter is equal to twice of a plus b. A plus b value we know, which is 9. So 2 into 9 is 18 centimeter. So this is the perimeter of this rectangle, which is 18 centimeter. This is the correct solution of this question. So now we are going to solve the 8th question. See the question here. A man walks 1 kilometer to east, and then he turns to south and walks 5 kilometer. Again he turns to east and walks 2 kilometer. After he turns to north and walks 9 kilometer. Now how far he is from his station point or starting point? So out of the 4 options, option C, 5 kilometers is the correct solution of this question. So let's solve this numerical. So basically there is a person, he went, so this is direction north, south, east and west. So there is a person is a starting position, and he went 1 kilometer to east. So again he went 5 kilometer to south. Again after reaching here, again he went 2 kilometer to east direction, and then again he went to 9 kilometer in the north direction. So in the question they are asking what is the distance between the initial and the final position they are asking. So basically if this is 2 kilometer, so this is also same thing, which is 2 kilometer. And if this is 5 kilometer, this is also 5 kilometer. But we know the total length is 9 kilometer. So 9 minus 5 will become, this is 4 kilometer. So this distance is 4 kilometer. So now by using the Pythagoras theorem, I want to know what is this distance d. So this total length is 1 plus 2, 3, and this is 4. So d square, by Pythagoras theorem, d square is equal to 1 plus 2, which is 3. 3 square plus, and this is 4 square. So therefore d is equal to under root over 9 plus 16, which is under root over 25, which is 5 kilometer. So therefore 5 kilometer is the distance between its starting position and the final position. So now we are going to solve the 9th question. See the question here. The population of a village is 5500. If the number of males increases by 11% and the number of females increases by 20%, then the population becomes 6330. So the population of the female in the villages. So basically initially males and females total population is 5500. So the male percentage is increased by 11% and the female percentage is increased by 20%, and then the new population will become 6330. So we have to find what is the female population originally. So what are the 4 options? Option B, 2500 is the correct solution of this question. So let's solve this numerical. So now I am going to assume M as the population of the males and F as the population of the females. So M plus F is equal to 5500. That is the first equation. And here the male percentage is increased by 11%, means 111 by 100 M, and the female percentage is increased by 20. So therefore 120 by 100 into F is equal to 6330. This is the new population. So it will become 1.11 M plus 1.2 F is equal to 6330. Second equation. So basically there are 2 equations with 2 unknowns. So if you solve this one, we are going to get the females is equal to 2500. These many number of females are going to present in the initially in this area. So therefore females is equal to 2500. So this is the last question of this lecture. See the question here. Mary introduces Jack as the son of the only daughter of my father's wife. So how is Jack related to Mary? So what are the 4 options? Option B, son is the correct solution of this question. So let's solve this question. See in the question they have said Mary introduces Jack as the son. So therefore Mary is a girl and the Jack is a boy. So circle indicates girl and square indicates boy. So therefore here Mary introduces Jack as the son of the only daughter of my father's wife. Of my father's wife is nothing but here her mother. So therefore this is her father and this is her mother. So therefore her father's wife is nothing but Mary's mother. So therefore here, so Mary's father and mother, so her only daughter is nothing but Mary. So therefore her son is Jack. So therefore this is the relation. So therefore Mary is going to introduce Jack as a, so Mary is going to introduce Jack as the son, is the son of the only daughters of my father's wife. Of my father's wife is nothing but, so Mary father and mother her daughter will become Mary. So Mary's only son will become Jack. So therefore Jack is the son of the Mary. So therefore how Jack is related to Mary? So therefore Jack is the son of the Mary. So option C is the correct solution of this question. So by this lecture we have successfully completed the 10 questions which are the questions of the ESE General Studies solutions of the 2021 in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notifications comes from mobile. If any improvements needed in our villages, then please do comment in the comment section. We will definitely include all those information in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.